Okay, so here we go. We're going to continue with section 10.3. How can you find the probability that when 5 cards are drawn from a deck, 4 of them will be aces? So here's a bunch of definitions: probability, theoretical probability, odds against, odds in favor, experimental probability. Theoretical probability is basically just based on theory, like things that you know. For example, if somebody asks you what's the chances of pulling a queen, it's 4 out of 52 because there's 4 queens in a deck of cards which has 52 cards. Odds against, sometimes you'll hear at the horse races, what are the odds of getting this and that? It's slightly different than probability. We'll take a look at that later. Basically what you do with odds is, in the numerator you put the number of outcomes not in A, when it's odds against, to the number of ways it could happen in the event. It could happen. Basically it's unfavorable over favorable for odds against. And if you want to find the odds in favor, you put the ways it could happen, or the favorable, over the unfavorable ways. We'll look more at that later. Experimental probability is when you have to actually conduct an experiment to come up with the probability. I'm going to highlight not here so you can see the difference. And geometric probability is the probability found by calculating a ratio of 2 lengths, areas, or volumes. So, take a second to do the warm-up. Okay, so here you go. These are the answers to the warm-up. Remember, when you find the decimal, you have to multiply it by 100. So that's kind of what I did. This is in decimal form already. Multiply by 100, it's 3%. This you could put into decimal form. It would be 1.4. And then when you multiply by 100, you get 140%, 83.3%, and 0.45%. Okay, let's start doing just a little bit of probability. This talks about a deck of cards. If you really can't remember the cards that are in a deck of cards, you can look at page 690. It's got all of them laid out. So here it says, what are your chances of picking an 8 out of 52 playing cards? So you got to remember that there's 4 8s in a deck. So there's 4 ways you could pick an 8, and that reduces to 1 over 13. You can just leave it as a fraction for that. And then here it says picking the chances of picking a red king. Well, there's 4 kings, but only 2 of them are red. So it's going to be 2 out of 52, which is equal to 1 out of 26 chance. And that is that, just basic probability for that. Okay, this one we're going to add a little bit more in. It says a cereal company plans to put 5 new cereals on the market: wheat, rice, corn, oat, and multigrain. The order in which the cereals are introduced will be randomly selected. Okay, so each cereal will have a different price. All right, so what is the probability that the cereals are introduced in order of their suggested retail price? Now that means that there's only one way this could happen. Like they start with the most expensive and go down, or the vice versa, the least expensive and go up. There's only one way that could happen. So that's what's going to go in your numerator. What's the chances of this one way happening? And then we have to figure out the total. Well, the total would be 5 factorial, because that's the number of ways that the cereals could be ordered. Number total ways that the cereals could be ordered. And that's going to go in your denominator. So the chances of this happening is 1 over 5 factorial, which is 1 over 120, which is the same as approximately 0.83%. All right, now this is a little bit different because it says, what's the probability that the first cereal introduced will be multigrain? Well, there's only one chance that you're going to get a multigrain out of 5 different types. So that simply is just going to be 1/5. All right, what's the probability? Oh, wait, let's move on now. Peter, are you listening? Peter! A standard 6-sided die is rolled. All right, find the odds in favor of rolling a 6. Now you got to remember that odds are slightly different. You don't put the total in the bottom, okay? For odds, you have to subtract, basically, is what you're doing. Or if you want to look at it this way, the top and the bottom add up to the total. So, remember on the other side I said, when we have odds in favor, we put the favorable ways, or the ways it could happen, on top. There's one way you could get a 6, and there's 5 ways you can't. So the odds are 1 over 5, or sometimes we say 1 to 5 odds in favor. Okay? And then let's think about the odds against. So for this one, we want to put the unfavorable over the favorable. Well, the odds against rolling an odd number, there's 3 odd numbers on a dice, and there's 3 even. So we're going to put the unfavorable, the ones we don't want, on top, and we want the odds on the bottom. So it's kind of odd because these, pardon the pun, these numbers are the same. But we would say 3 to 3, or 1 to 1 odds in favor of this happening. Okay, the blood types for a sample of donors at a blood drive are displayed in the bar graph here. Find the experimental probability that a randomly selected blood donor would have type O. So you kind of have to look at this and say, all right, here's type O, A, B, and AB. So we just want to know the probability. That's all we want to know. So we're going to find out the chances of it happening. So right here for O, there's 22 possibilities that it could happen out of a total of 50 when you add these all up. Okay, so then we just reduce that. Put it in decimal form, and then in percentage. 44% chance of a type O. All right, easy enough. All right, the last thing we have to do is geometric probability. Find the probability that a dart thrown at the rectangular board hits one of the triangles. Assume that the dart is equally likely to hit any point inside the board. So say we throw a dart here, and we want it to hit inside one of the triangles. So we're going to find the geometric probability of that. So what you do is you take the total area of the triangles, and you divide it by the area of the whole rectangle. Okay, so let's finish this. The first thing we have to do is find the total area of the triangles. Remember, you find the area of a triangle as 1/2 base times height. So I'm going to label this triangle A, triangle B, triangle C. So for triangle A, it's going to equal 1/2 base times height. So I'm just going to look at this and I'm going to say, okay, it doesn't matter what you choose for the base or the height. And you get 2 times 3, which is 6. So that's the area for triangle A. The area for triangle B would be half of one of these numbers, because this is 8, and this is 5. So I'm just going to cut this one in half. 4 times 5 is 20. And then triangle C, half one of these, and that's going to say that's 2 times 3, which is 6. That's also 6. So I already decided that I need to add up the area of all the triangles and put that in the numerator, because that's what I want to shoot for. So that's going to be 6 plus 20 plus 6 divided by the area, the total area of the rectangle. 40 times 10 is 400. And so that equals 32 over 400, which is 0.08, which is 8%. It seems kind of reasonable. You have about an 8% chance of throwing a dart and hitting one of those triangles. Look at that. Shortest video ever.